Okay, so in this video, I'll be showing off a blockchain-enabled space bucket. This is kind of just a side view of it. And I'll come over here to get a front view and give a breakdown of what it is. What a space bucket basically is. It has its own little community. There's a bunch of do-it-yourself indoor gardeners. And what people generally do is they'll go out and they'll get a 5-gallon plastic bucket from like a hardware store. This is from Home Depot. And they'll put some fans on it and they'll put a light either on top of it or kind of in the inside. And then they'll throw a little dirt in there and they'll grow a plant. And generally most people grow pot plants in there, but you can do other stuff. And so this was our project for at Denver, which was an Ethereum blockchain hackathon in Denver about a month ago, February 2018. And we wanted to do an IoT project, and so we thought this would be pretty easy to build in a weekend and pretty cool for Denver and a hackathon. And this is what it looks like. I'll kind of give you a breakdown of how the bucket is built and works. At the very top here, this big thing right here is just one big heat sink. It was about 20 bucks. This is just a regular 5-gallon lid. I attached it to it, and then attached to the heat sink is a cob LED. And these things are starting to get really popular now because they're very energy efficient, especially for indoor lighting and indoor horticulture. This cob was probably about like 10 bucks. And if you look closely, it's actually like a matrix of like 100 little really small LEDs. And this is a 100-watt LED, but I only run it at about 60 watts. So I'll set that down. And then for like the general construction of the bucket, I just use some pretty simple tools. This is them. A Dremel being the most important, just a Dremel 100. So what I'll do is, once I've made my designs, I'll take a Dremel with like a 1/8 drill bit and kind of drill in and then mill out the bulk of it. And then sometimes wire cutters will help to get off the chips of plastic and some other parts. And then what really kind of helps, it's time consuming, but it's for perfectionists, it's something called a nibbler. You can cut sheet metal with it too. And I'll try to show it cutting here real quick. And what it does is you just get on there and then kind of just nibble away, what you want, the edges here. And then for the fine detailing, I'll just use a number 11 X-Acto knife and just start carving off the edges to get it nice and fine. And then most people on their buckets, they'll have their light, and then they'll have an intake fan, which is right here, and they'll have an exhaust fan to help get the heat out. And it's just a PC fan, and I used 80mm fans, which is a little bit smaller than what most people use. The reason being is because the buckets out here in the Midwest are kind of different than what buckets most are, but this is 80mm. It's perfect for an 80mm fan. So this is my top spacer. As the plant grows, you put these spacers in and they just stack up. So I have those two fans, and then it's kind of hard to see, but I 3D printed adapters, so these fans just latch right on and then screw into the bucket. And then going inside the bucket, first off we got what I would call a hydro halo, but it's really just a square. And I also have a Arduino Nano here, and it has a DHT11 sensor, so it's got temperature and humidity, a soil moisture sensor, and it's just a kind of inexpensive 2-prong type. And then there's just a really cheap photo cell right there to measure the light intensity. And so this halo is connected to this water tank. It's got a like a $15 water pump that can run on 5 to 12 volts. And then the Arduino Nano here is connected to a Raspberry Pi, which is kind of the heart of this thing. I'll get to that in a second. As my power adapter is attached on this side, this is the 36 volt power adapter for my 100-watt LED. And And then on this side, this power adapter here, I actually got the Raspberry Pi. I needed 4 relays. The Raspberry Pi has 3 on it, and so I got a 4th relay. And I went through Adafruit and got this one. This is pretty cool. It's like a heavy duty relay. And this is for the LED light. So this plug is for the LED light. This is a, and this relay here only controls this light. These plugs right here are always on. This is a 12 volt, half of an amp that powers the fans and pump. And this is, below it is the 5 volt power adapter for the Raspberry Pi. And the Raspberry Pi has this 3 relay board attached to it. It also has our Arduino Nano, and then a USB drive. And I run the Ethereum node on the USB drive. So yeah, I'll put the lid back on. We'll see if we can take her for a test drive. So there's our bucket, and we'll get back to it in a second. So this bucket is, this Raspberry Pi is connected to the internet right now via Wi-Fi. And this is kind of important for this whole concept. And it's connected to my home Wi-Fi network. And it's just a kind of standard residential network where I got my cable modem. It's a dynamic IP address from our ISP provider. And then there's no port forwarding going on with that router in my network. So this whole bucket is protected behind a firewall. And the only port that's really open on it is the SSH. So you can get online and explain what is going on with the blockchain on this thing. So this is kind of our project page, Decentralized IoT Horticulture. Here's the page for space buckets. So typically what happens is when people want to do an IoT project, you can either do it kind of like direct connect. I'll show you an image. A good example of an IoT product now is kind of like a Wi-Fi enabled thermostat that a lot of houses have, especially smart homes. And that's kind of like what the bucket's doing also. The bucket, you can control the temperature and the fans and also monitor the temperature. So in an IoT example like this, the thermostat, there's 2 ways to access this thermostat when you're away from your house. You can do a kind of direct connect, but in that case, you would have to open up ports on your router and enable port forwarding. So what most IoT devices do now is they'll relay their information up to the cloud. And if you issue controls to that thermostat, they'll get relayed through the cloud. Here's another example of a do-it-yourself Wi-Fi thermostat, where if you were using Wi-Fi, again, this cloud server would come into play, especially via your cell phone. But in this instance, cloud servers are kind of insecure. If it's a single point of failure, so if there's a denial of service attack or if a hacker gets control of it, then all the devices connected to that cloud server are compromised. So instead of using a central server like that, we decided instead to use the blockchain. And how we did it was we just made a smart contract. Instead of setting up a cloud server for our backend, we write a contract using Solidity, and then you post that contract onto the blockchain, and the user can interact with it, and the bucket can also interact with it. So, real quick, this is the contract. I'm going to SSH into the Raspberry Pi real quick. So it's just in my local Wi-Fi network to give you an idea of what's going on. So right now on the Raspberry Pi, it is running the Geth binary, which is the software that you run if you want to run a Ethereum node. And I can run htop real quick and show that. And it really doesn't take up that much CPU, especially, but I'm on the test network. So here's the commands for that. And I mentioned that I run it on a USB drive. So when I initially boot up the Raspberry Pi, it runs a quick start script, start Geth, where it mounts the USB drive. I also partitioned off part of the USB drive to be swapped to handle some of the memory. But here's the Geth command where we're using RinkB, like KDF. option to like, so the keys are easy to unlock. Max Pearson telling the data directory that's on USB and unlocking the account that I use to send data to the contract. So we have an instance of Geth running on there. So for our backend, which is just a smart contract, this is the source code for it. I'm on Etherscan right here. This is the Rinkeby Etherscan. This is the contract address, which kind of acts like our cloud server, our relay, our storage for our data, and when we want to send a message to the space bucket. And the code that we wrote for this is short. It's only about, well, here it's 175, so about 150-ish lines of code. I won't go into too much detail about it. One of the things that is important about it is there are events in here. So if things happen, like the temperature changes, the bucket will edit this contract and an event will be triggered. And we have, there is a front end that listens for it. So real quick, I'm just going to show that the Raspberry Pi is synced up to the Rinkeby network. So I'm going to attach to the instance of Geth that is running right now, and then I'll run F and get the block number that it's at. So we're at 201.5377. I'll go Rinkeby real quick on Etherscan 370.76. So yep, it is synced. And so to give an idea of what is happening, basically this contract is relaying the information. The bucket is listening to this contract and paying attention to it to see if it updates or changes. And the user would be doing that remotely. And also the user, with the environment changes in the bucket, that will get edited in the contract also and get posted on there. So normally when you post a contract like this with functions like get temperature, set humidity, is light on, is fan on, we have values like that and functions like that. So I think it's pretty easy to understand. It's only 175 lines. If you're decent at programming, you'll get it. And once you have a contract like there, right off the bat, the standard way that people will interact with it is they'll use something like My Ether Wallet. So this is kind of a crude front end, and you'll see here I'm set to Rinkeby. And if I go to contracts page and copy the address for this space bucket contract, and then go get the ABI, and paste that, access it, there'll be a list of all the functions that we wrote for this space bucket, such as get soil moisture, where the bucket ID for this particular bucket is number 9, and the soil moisture is at 86 right now. So, but My Ether Wallet is kind of clunky. So what you'll do is you'll write your own front end, and that's what we did. We wrote our own specific front end for that space bucket, and we will go to it now. And you'll have to have MetaMask installed if you're from a desktop. So what the scenario would be is you would be at work right now, and we'll pretend like this is our work desktop, and the space bucket is at our house. And so we're at work, and we want to know what's going on with our space bucket and if we need to change anything on it. So we'll visit this site, the BucketNet, and bloop. And that is the current temperature and humidity of the bucket right now. And so if I were to decide, oh, it's getting too hot in the bucket right now, and I want to turn the intake on, and we'll do it right now. We'll do intake, and then MetaMask will come up, and I'll have to pay a tiny transaction fee for changing the state of the contract, edit this contract. And in about 30 seconds, and we gotta wait for the block to get mined, this fan will turn on. And so now I'm going to start going through and turning on all the parts on this bucket. It's a little bit, oh, there it goes. So that all happened remotely, basically. And as you can see, the green intake button is on. And now I'll turn the exhaust on. So, like I said, in this example, you would be doing this remotely. You could be across the world and you could, you know, access this web page and decide, oh, I want to turn my fans on and stuff. And then we should see the exhaust come on soon in the next, hopefully, less than 15 seconds. And then I'll turn the light on and then we'll do a little watering. And then I'll show you the mobile version and then we'll be done. So hopefully we'll get this wrapped up in under 20 minutes. So we're waiting. And so, oh, there it goes. That's one of the little disadvantages right now about the blockchain is it's a little bit slow, 15 seconds. But I think the default for Amazon AWS IoT service is 1 minute is the refresh rate. So I think you can adjust it to be shorter than that, but that's the default. So I'll turn on the light now, and it's a powerful light. And after I turn the light on, so it'll take about 15 to 30 seconds for the light to plop on, and then another 15 seconds later, you'll see the light intensity shoot up. And then very slowly the temperature might start to go up. So now we wait for the light. And typically what people will do is they'll paint or wrap their bucket in black tape. And you'll see why when the light turns on. Yeah, it's pretty intense. And this should hopefully catch. Nope, and there we go. So now if I were to check the status of this bucket, you know, another time, it would. So if I close this tab and then go and get this address again, and then went to lunch and came back, and then visited the site again, it would show what the current status of the bucket is. And as I mentioned, we should see the lights intensity shoot up, and then I'll turn the water on. And real quick, to explain what's happening on the Raspberry Pi, it's simply so we wrote the smart contract in that Solidity code, which was this chunk of code here. So that's that part of code that we wrote. And then I had to write a little bit of code for the Arduino. And then the other part of important code was we have to write a NodeJS file, cd. And I'll cat it real fast and try to go over it as quick as I can, and then show off the mobile version in this thing. So this is the JavaScript file, and then it's pretty easy to understand. So most importantly, we bring in the Web3 library, which allows this JavaScript to interact with the Ethereum blockchain. And then here's the GPIO library to control the pins on the Raspberry, serial port and Arduino, so we can listen to the Arduino sensor. There's some dynamic DNS stuff here, because we started to dabble in dynamic DNS. So we could do a peer-to-peer connection if we wanted to. And then here we're setting where our Web3 provider is. And because it's running, we're running a node on the Raspberry Pi, we'll just set it for localhost port 85. This is the ABI, which is kind of like the function definitions for our contract. This is the contract address on the blockchain. And then here I'm just setting where the fans are, what pins they're at and whatnot. A little bit of dynamic DNS stuff. And then here is where the JavaScript starts calling functions and on that smart contract, checking what the state is. These are kind of like functions that would run as it boots up. And then after that, these are listeners that are listening for events that are triggered from that Solidity smart contract that's on the blockchain. Events like light toggled, or exhaust toggled. And then down here is just the sensor data, where if the temperature changes by a significant amount, it will post that new temperature onto the contract. And that's it. That's the JavaScript code that we're using. So now I go back to the page. My light intensity is way up now, so back to 908. I'm actually going to turn the light off before I shut off the water pump. So I have to wait another 30 seconds. This is one of the reasons I don't like. It's kind of, my blockchain videos are long. Waiting for the block to be mined. So just to show real quick, there's that light. And this is very bright light. I mean, this is enough to, that's enough to grow a plant. So waiting. Hopefully another few seconds here. There we go. I'll quick turn this off. And then the way the water works is it just does a burst of water. And then I'll do a submit. So I toggled the water, and what the water will do is it does like just a 3 to 4 second burst of water, and hopefully we'll hear it and see it kind of. Let's see if I can get a good view. And then after the water dispenses about another 30 seconds. After that, you'll see the soil moisture change. So, any second now. There it goes. So now the plant has been watered. And then you should see the moisture change. Well, the moisture will change. There's actually a debug when I run the NodeJS file. I have some console messages that print out there, and you can see the soil moistures going down, or whether or not it's going to 64. So that's changing. I'm showing it's work. Real quick, go to the mobile version real quick. So, I'm going to, there it goes. It changed. And you see the temperature went up too. It went up to 77 since that light was on. Now the light's off. I am actually going to use a new contract now. So I'm killing this Node.js, and I'll show you the mobile version and then end the video. Now I guess it's going to be 30 minutes, 20 minutes. So then. And all this stuff will get put on the Git and links, all that. So this is all open source. So you may have heard the clicks. The bucket just synced to another contract. And that contract is actually, I'll close this real quick. Go to the Space Buckets page. Is on, I'll show you the mobile way we do this. So there is an app called Cypher. And as you can see, it's set to Rinkeby network, and they have their own Web3 browser built into it. And you can see I already bookmarked BucketNet. And now, so the temperature was at 77. Oh, it's gone down to 75. Yeah, now I can do it mobile from my phone. So according to this, intake, exhaust, and light are on. Actually, the light wire unplugged accidentally just now, and I will turn off the exhaust, and then we'll say approve this, approve. Oh, unlock. And there you go, I'm doing it from mobile, and hopefully this exhaust fan will stop in 30 seconds, and that will be that, folks. It's waiting. Come on, exhaust fan. There it goes. Exhaust is off. All right, so there you go. And so that code, what was that? Probably just like 300 lines of code, if that, to make the back end and the front end. Well, the front end was made with React. There's a lot more lines of code for that, but yeah, it's pretty easy. So thanks for watching. Yeah, Decentralized IoT Horticulture. Shame we didn't win, but thumbs up if you like. Thanks again.